Hi, Set 1 Sparks. Welcome to Forensic Science. This is on blood splatter and I am Miss Yong. Before we go into blood splatter, I would like you all to go through the thinking routines again. That is to identify and understand the scene, list down the assumptions and variables, select and organize the information and theories, hypothesize, form the links and infer, synthesize what took place, verify the sequence of events, and present the reenactment. So these are the things that you should go through in your mind when you're trying to come up with what is happening based on the blood splatter scene that you see. Okay, so now let's move on. What is a blood stain pattern analysis? Now, it is the interpretation of blood stains at a crime scene in order to recreate the actions that cause a bloodshed. So analysis will examine the size, the shape, the distribution, and location of the blood stains to form opinions about the following questions, like where did the blood come from, what causes the wound, from which direction was the victim wounded, how was the victim or how were the victims and perpetrator positioned, what movements were made after the bloodshed, how many potential perpetrators were present, does the bloodstain evidence support or refute witness statements. Now, why are we interested in blood? Now, first, we have to understand the basic properties of blood. Blood is in a liquid state when inside the body, and when it exits the body, it is still a liquid. So, for anyone who had a cut, you'll notice that after some time, the blood will stop flowing out from your body and it will start to clog at the wound. But for people with hemophilia, their blood will not clog. It will just continue to flow and flow and flow. That's why for these people, it's very dangerous for them to have cuts because they may die of bleeding. So now, the presence of blood clot in the blood stains can indicate that the attack was prolonged or that the victim was bleeding for a long time after the injury occurred. So, depending on how the blood leaves the body, we can determine how the type of injury is inflicted onto the body. Okay, so, the types of stain. One is the latent blood stains, meaning that you cannot see with the naked eye. So you will need to use a chemical reagents, luminol, to spray on it so that you can photograph the latent blood stains. Okay, so before spraying, you cannot see the blood stain at all. But after spraying, you'll be able to see a bright blue luminescent glow. I'm going to show you a picture of it. Now this is a picture of the blood stain. So before spraying the luminol, you cannot see it at all, but after spraying you'll be able to see the luminescent glow. Okay, now for blood stains, it can be classified into three basic types. There's the passive stains, transfer stain, projected or impact stains. Now passive stains, they are drops, pool or flows. They are typically as a result of gravity acting on the injured body. That means it dropped downwards, vertically down. And these are some examples of the passive stains. For transfer stains is as a result of objects coming into contact with the existing blood stains and leaving wipes, swipes, patterns transfer such as the bloody shoe prints or smell from body being dragged. So like your hand accidentally swipe over it, or you use something to wipe, or your shoe, right? You notice when your shoe step on it and then you transfer the pattern, the blood stain to another place. Projected stains or impact stains is as a result of the blood projecting through the air. So it will form a splatter. Okay, like this is a low velocity. You can see there is quite big drops, medium, and this is the high velocity. They are usually finer, smaller drops. Now, velocity refers to speed. Okay, you'll learn more about velocity in the upper sec, but for now, you just take it as it is the speed. It tells you how fast the blood is being projected out through the air. So if the speed is slow, yes, there's a bigger drops, and if it's fast, finer drops. Yeah. Now, one of the projected stain would be gunshot splatter. Okay, there is the forward splatter, which occurs on the acid wound. So when your bullet enters from here, this is when it comes out from the body. This is called the forward splatter. The back splatter is the one that is at the entrance of where the bullet enter the wound, the body. So the back splatter has less blood coming out, okay, and the forward splatter there will be more, and the area they cover can be very big, depending on the type of gun and the distance between the victim and the gun, as well as the location of the victim to the walls, the floors, all this. So usually for the forward splatter, it's a fine miss. The back splatter is larger but fewer drops. Now, another example of projected stains would be cast off. Cast off stain is when the criminal use an object, in this case, for example, a hammer, to hit the body, and when he lift it up, some of the blood is being projected onto the walls nearby. And then when it moves forward and backwards, it will create a few more stains. Okay. Now, and depending on how fast the criminal move the object, the weapon, forward and backward. So if the criminal move the hammer backward slowly, it will have larger droplets. If the criminal moves the hammer backward very quickly at a very high speed, fast speed, the droplets will be smaller, finer. Now next will be the arterial spray. This refers to the spurt of blood released from a major artery. Somewhere, the most common one would be near your neck. There's a very big blood vessel. That's why if you happen to have somebody use a knife and cut across it, a lot of blood will be propelled out. Now this is a picture of the arterial spray. You'll notice that it's actually be very big blood stains and it is moving. So that means the victim didn't stay in one location. After being cut, the victim continued to move, and then because of the vessel is connected to the heart, so when the heart continues to pump, the blood will just spray out. Okay, and the next one, aspirated splatter, is usually caused by blood from an internal injury mixing with air from the lungs being expelled through the nose, the mouth, or any injury to the airway or lungs. So aspirated splatter is usually in a form of very fine mist due to the pressure exerted from the lungs moving the air out of the body. So small air bubbles in the drops of water are typically found in this type of splatter. Now for void pattern. Now void pattern is actually a features an area free of splatter. So if you look at this blood stained picture, you will notice that this portion, there's no blood at all. Right, so this is the void pattern, which is free of the blood splatter because it's being probably blocked by an object, so the blood didn't get to that side of the wall of ground, or it could be the person blocking it. Now another projected stain would be the satellite splatter. So if you look at this diagram, right, you'll notice that the small drops, all this, that is being distributed around the other drops of blood, the parent drop of blood. They are called the satellite splatter because they're all scattered around. It is produced when the blood hit the surface and then bounce up. Yeah, so the drop reach the surface here and then they bounce up. Okay, this is called satellite splatter, and the spikes refers to the pointed, this pointy part. Okay, so this can be used to determine the direction from which the blood travel. Now, for bloodshed events, a crime scene where the bodily injury has occurred is likely to produce a certain amount of blood stain. Okay, they should be able to find some blood stain evidence there as well. So the amount depends on the circumstances of the crime, the type of injury inflicted, and the amount of force used will determine the volume and the pattern of blood stains. So previously when we talked about the projected stains, okay, we talked about like cast off, we talked about the gunshot injuries. So depending on the weapon used, it could be a sharp force injury, stabbing. It can also be a blunt force injury that is used by an object that has a larger surface area. For example, a hammer or maybe vase, or I don't know, some ornament, some very big object and heavy, and then the criminal just use it and hit the victim. So usually for this type, right, there will be more blood coming out, and the blood will have various sizes, the drops. Yeah. Compared to the sharp force injuries that is caused by a smaller surface area weapon, less blood will come out. You see, there are smaller, more linear patterns of the stain. Now, gunshot injuries, I've talked about it previously, is mist-like splatter. Alright, how to analyze blood stain pattern? 1, analyze the pattern analysis. 2 is reconstruction. So pattern analysis, look at the physical characteristic of the stain patterns, including the size, the shape, the distribution, overall appearance, location, surface, texture where the stains are found. Then through all this, the analysis can interpret what pattern types are present and what mechanism may have caused them. So like in this picture that you see, it tells you that the diameter of the blood stain increases as the height increases. So if the blood is dropped from a very high level, the blood stain, the blood drop will be larger, the diameter. But if it's dropped at a shorter height, okay, very, very near to the ground, then the blood would be smaller in diameter. Now this is a picture of all red ink stains pattern on different surfaces. This is red ink, not blood. So if you look at like on a cardboard compared to on a cotton cloth, you will notice that the cotton cloth, the blood drop is actually smaller in diameter than the cardboard. The glass, you notice it is larger. Metal only partial. Tin paper on the floor, white towel, wood, skin. Yeah, notice different surface. When you drop at the same height, the diameter of the blood drop is different, and depending on the surface, whether is it rough or smooth, there's also a difference. Like this is on the wood, which is rough surface, compared to a smooth paper. You notice there's satellite splatter, there's the spike. Now I'm going to show you another one. This is the blood stain. The stains are formed by human blood, not red ink. So if I put it beside the red ink, you can actually compare. You see the polished shoe, the thick smooth paper, cotton cloth, comparable, right? Then this is the you look at the matter, the human blood on metal surface compared to the red ink on the metal surface, tin paper, ink on tin paper, human blood on the floor, ink on the floor. Okay, so blood splatters may be able to show surface information such as the type and velocity of the weapon, number of blows, left-handed or right-handed, position and movement of the victim, and attack during and after the attack, which wound were inflicted first, types of injuries, how long ago the crime was committed, whether the death was immediate or delayed. If the blood falls from a distance, the blood will be smaller in diameter. Hard surface will keep more of a circular shape, while carpet absorbs all of the blood and makes the edges spread. So through the blood splatter analysis, you will be able to learn more about what happened then. Okay, depending on how the blood stain is being found, you can actually calculate the angle of impact. And of course also depending on the surface. Just now we talked about the surface. So so you'll notice that if it's vertically on top, of course it looks more like a circle, more to you. But if it's like at an angle 40 degrees, 10 degrees, you'll notice it's more and more elongated. So now I'll show you how they calculate the angle of impact. So initially when the blood leaves the body, it is of course in a spear, right? Then when it hits the surface, it becomes elongated depending on the angle of impact. Okay, so angle of impact is this. From here you can see, right? Okay, then from top, this is the stain. Okay, this is how it looks like. Let me introduce to you first. This is the secondary splash. Okay, it tells you the direction of the spray. Then, so you see, notice after it splatter, like this is the parent drop, and then it hit the surface and bounce up. Okay, so this is the secondary splashes. And so length, this is the length of the droplet, this is the width. So the angle would be sine angle over equals to width over length. So to find the angle of impact, you have to press a calculator, inverse sine W over L. So the angle of impact will tell you whether did the criminal actually hit the person from top down, or from at an angle, swing from left side to right side. So through it you can calculate but the direction, whether it's a left-hander or right-hander. Now next is to reconstruct using the analysis data put into contextual explanation to explain the stain patterns, right? What type of crime, where's the person bleeding from, did the stain patterns come from victim or from someone else, are there other scene factors like emergency medical intervention, anybody help, or did somebody come and clean the crime scene? Now to help reconstruct events that occurs the bloodshed, analysis use the direction and angle of the splatter to establish the areas of conversion, the starting point of where the blood comes, the origin or the estimation of where the victim and the suspect is when the blood comes out. Okay, so if you look at this diagram, okay, I'll show you another one. So the analysis will identify a few blood stains whom he thinks will contribute to where he can find the area of convergence, because some stains are just secondary splatter, or the satellite splatter. So he needs to identify the parent drops. So these are the parent drops that he used to determine the area of convergence. Another example. Now, this is how they find the area of convergence, the trajectories, and determine where the victim is standing and where the criminal holds the gun and shoot. Okay, now moving on. There are limitations to this analysis. You cannot recreate the entire scenario because there are unknown variables that analysis cannot account for using the scientific methods. For example, whether the perpetrator is old or young, whether the attack is planned or spontaneous, like on the spot, then act on impulse, or they plan to kill in the first place, or is it under the influence of drugs or alcohol, unless they have the blood that contains the blood or drug left behind, then they can test for it. So the results of all these analyses are usually used to support or confirm the findings of other forensic discipline, other evidence that has been found, and also testimonials from the witnesses. Now I've come to an end of bloodstain analysis. I hope you have enjoyed this and have a better understanding of how analysis, how the forensic scientists work